Assalamu alaikum everyone. I hope you all are doing well and taking good care of yourselves. This is your instructor Ali Faruqi and you are watching Science with Ali. This is the part 4 of redox reactions. So a quick recap of what we did in part 3. First, for the first time we looked into how redox reactions work in chemical equations like these, in which for the first equation we oxidized sodium because it was there was a gain in oxidation number, as you can see, because in oxidation there's an increase in oxidation number, and for reduction there's a decrease in oxidation number. We also looked into the second chemical equation, in which it was the same story. We just first of all we located the elements in the equation. We took a 0 on it, so because the first rule of oxidation number is that oxidation number of an element is always a 0. Next, we put the charges on magnesium, which is a +2, bromine was a -1, chlorine was also a -1 because they both belong in group number 7. And with the help of this number line, we came to the conclusion that magnesium was being, bromine was being oxidized and chlorine was being reduced. And lastly, for the last point of oxidation number, we discussed that the oxidation numbers in covalent compounds is the number of electrons shared by an atom, where we simplified the whole idea by saying that oxygen will always be assigned a value of -2, where a negative sign and a positive sign for covalent compounds does not mean that the electrons are lost or gained. However, it is based on electronegativity, which is not in our syllabus, so we don't have to worry about that. Next up, we also did some examples of carbon dioxide and then carbon monoxide, in which we constructed the mathematical equation involving X to figure out the oxidation number of carbon in both the equations. So I'm pretty hopeful that and next, for example, we did this past paper question, which involved making a curve for sulfur's oxidation numbers in the process of making H2SO4, sulfuric acid. So we just basically assigned the values. We made an equation for the SO2, SO3, and then sulfuric acid, in which we looked into what the oxidation numbers for in each of the 4 stages were listed. Next, we made a curve. The curve looks something like this. So in the last class, I left you with some equations. I left you with 2 equations. So I'm pretty hopeful that you attempted them. The first equation was Mg plus 2HCl will give us magnesium chloride and hydrogen. So the first step in the chemical equations was that first we have to locate the elements, the separate elements in this. So in this I can see 2 elements, magnesium and hydrogen. So I'll just go ahead and assign them a value of 0 because they are an element, and the first rule of oxidation numbers was that every single element has an oxidation number of 0. So because chlorine belongs in group number 7, so chlorine belongs in group 7, so it has a charge of -1 over here and -1 over here. Mg will have a charge of +2 because it's in a compound right now, and it belongs in group number 2. And in this, hydrogen will be +1, right? So let's just look over here and try to figure out what is getting reduced and what is getting oxidized in this very equation. So as I told you, you should isolate just one element on the product side and then the same element on the reactant side as well. So in this, you can see that magnesium has a 0 over here and a +2 over here. So because oxidation is an increase in oxidation number, we can say that magnesium has been oxidized. As for what is being reduced, first I would isolate the same element on both sides. First, let's go to chlorine. Because chlorine is unchanged on both sides, it has a -1 and it is a -1 over here. It is not going either reduction or oxidation. So we will just leave chlorine as it is. Next, we move on to hydrogen. So hydrogen has a +1 over here and a 0 over here. So because it's going from +1 to 0, it is decreasing, right? So we can say that hydrogen is being reduced because there is a decrease in oxidation number happening. Okay, Now moving on to the second equation, I told you that the first step was to locate the elements. I can see two elements over here. There is calcium and there is hydrogen. So just go ahead and write the value of 0 on top, because oxidation number of an element is always 0. So let's just go ahead and write down the charges of all the relative compounds. So there's an oxygen present, so it's going to be a -2 for oxygen, and for hydrogen is going to be a +1 in order to balance it. And for in this very compound CaOH2, calcium hydroxide, so Ca belongs in group number 2, so it's going to be a +2, and hydrogen is a +1, and oxygen is a -2. We'll just write down the relative charges because all of them belong in groups, so they all have a charge present. So what is the increase in oxidation number over here? As I said, just isolate one element. Let's go with calcium because it's the first element that we see over here. So calcium is a 0 over here and a +2 over here. So because there is an increase in oxidation number happening, it's going from a 0 to +2, we can say that calcium is being oxidized, right? As for what is getting reduced, we can now isolate the other element. Let's go with hydrogen over here. It's a +1 over here, and hydrogen is a 0 over here. So we'll just go ahead and write down hydrogen is being reduced because there's a decrease in oxidation number happening. It's going from +1 to 0. Okay, so I hope that you got the homework correctly, because these were two very simple equations. There were no transition elements involved. There was no calculation involved to find out the oxidation number for an element. So this was very simple, and I hope this makes sense to you. Now I will continue doing the same thing and the chemical equations, and now we will do this together. So I would recommend to solve these with me so you can also get an idea. So just grab a pen and pencil so you can just write down the equations and get an idea as to how redox truly works in chemical equations. The first equation that I have is as follows: fluorine plus potassium iodide will give me potassium fluoride and iodine. Okay, so just go ahead and explain the charges. I will just write down the groups right now. So iodine and fluorine belong in group number 7. So they have a charge of -1. Okay, let's shade them red. Now, the first thing that we know is isolate the elements. I can see two elements over here. I have fluorine, I write down a 0 over there, and I write iodine as 0 because they are both elements and unbonded. They contain only one type of atom, as we discussed in the previous class. So for potassium, I have it belongs in group number 1. So for potassium, there is a +1. Iodine, because it's -1, so it will be a -1 over here. Fluorine is also belongs in group 7, so it will be a -1, and potassium will be a +1. So now let's figure out what's being oxidized and what's being reduced. Isolate one element, fluorine over here and fluorine over here. It's going from a 0 to a -1, so it is decreasing. So there is reduction going on over here. Reduced, fluorine is reduced. Moving on to potassium, it's a +1 over here and a +1 over here. So potassium remains unchanged throughout the reaction, so it is not even going oxidation and not even undergoing reduction. So we'll just leave potassium as it is. As for iodine, it's going from a -1 to a 0, so it's increasing. So oxidation number is increasing, so we can say that it is being oxidized. Iodine is being oxidized. I hope that's very clear. Moving on to the second equation, I have over here zinc plus copper sulfate will give me zinc sulfate and copper. Same story over here as well. Locate the elements. I can see zinc and copper. I'll just write down 0 and 0 on top of that. But now I can see that there is a radical involved in this, right? There's SO4 involved in this. Because SO4 is a radical, it has a charge of minus 2 overall. I hope you know this because this is a very important term that we need to remember in redox reactions. There's a list of radicals that you need to remember. Let's just write them down over here. So we have SO4 minus 2, NO3 minus 1, NO3 minus 1. Next we have carbonate, you have hydroxide, and you have ammonium, right? Now in this case, in the above reaction, I know that SO4 minus 2 is a radical and it has an overall charge of minus 2. So whenever you see any of these in a chemical reaction, immediately look over on the product side and the reactant side and check if the same radical is present on both the reactant side and the product side. In this case, SO4 is present on the product side as well. So I can just get away, you can say, by writing a minus 2 overall of SO4 on the whole of SO4 because the overall charge of SO4 is minus 2 and there's two of them present on either side of the reaction, so we can just call it a day and write down minus 2. Now for the rest of the chemical equation, if SO4 is minus 2, then copper will also be automatically be a plus 2, because how will the compound be 0 if it's not a plus 2? For zinc, it's also the same story because SO4 is minus 2. It will be a plus 2 because how will the compound be 0? Again, the same thing. So what is being oxidized and what is being reduced here? I hope the radical thing is very clear. You need to remember these all. So I'd be better off if you just take a note of this and learn. It's just like a couple, so just learn them, right? These are not all. There are a few, but we will come across all of them one by one as we go along in the lesson. Right, so where were we? We were in the oxidation and reduction stage of this reaction. So just put down the isolate one element. Zinc, for example, is going from a 0 to a plus 2. So it is being oxidized. Zinc is being oxidized. As for copper, let's go with plus 2 is over here and it's 0 over here. So it's going from a plus 2 to a 0. It is decreasing, right? So copper will be decreasing. It is reduced. As for sulfate, like I told you, you will look at it as a whole, not separately as oxygen and not separately as a sulfur. You will look at it as a whole because it's present on both sides of the reaction. So we'll just leave sulfate as it is and call it a day. Let's move on to the next reaction. I do hope what I have done over here is very clear. Okay, brilliant. Let's do a couple more examples. This is example number 3. Sulfuric acid plus 2NaOH will give me Na2SO4 plus 2H2O. Okay, so I'm dealing with two different radicals here. One is sulfate and one is OH minus 1. So now let's look at OH here. Let's look at sulfur here. Now I do know that sulfur is present on both sides of the reaction. It's over here and it's over here. Let's just go ahead and write minus 2 on the whole of sulfate. Now let's look at OH over here. Now I know that OH has a charge of minus 1. But as I told you before, do I have another OH on the product side? The answer is no. There is not another OH as a compound present on the product side. So there's only one OH in the entirety of this reaction. So because there is not another OH present on the product side, I will have a look at OH separately. I will just forget that this is a radical and just solve it like normal. Okay, like so. Oxygen is a -2 and hydrogen is a +1. Hydrogen over here is a +1 as well. Sodium belongs in group number 1, so it's a +1 over here. Sodium is a +1 because it belongs in group 1. Oxygen is a -2 and hydrogen is a +1. Okay, now I would tell you that make a note of this right now. Note is that if a radical remains the same before and after the reaction, then the overall oxidation number can be used. Like so we did with the first equation, in which we had sulfate present as a reactant. It was the same before, it was the same after, so we used the overall oxidation number, which was a -2. As for the second equation, we also did the same thing. We had sulfate over here as well, sulfate over here as well. We just got away with writing a -2 because it remained unchanged during the reaction. Now as for OH, because it's changing, I don't see an OH anywhere in the product side, so I will not be using the overall oxidation number. Why? Because simple as that, it's changing and we will have to do it separately now. Okay, so I hope that's clear. So very quickly, what is getting oxidized and what is getting reduced? Isolate one element from the start. So hydrogen is a +1. I can now look at hydrogen, it remains a +1, so it's not getting oxidized, not reduced. For the whole of sulfate, is the same as we discussed. For sodium is a +1, sodium is a +1 over here, and oxygen is a -2, oxygen is a -2 over here. Hydrogen remains the same as well, hydrogen is over here, hydrogen is over here. Now what we notice over here is there is not any oxidation number is increasing or decreasing. So let's just go ahead and write no change in oxidation number. So we can successfully call it a non-redox reaction. Because for a redox reaction, you need the oxidation numbers to change. And as we discussed and as we looked at previously, there was no change in any of the elements' oxidation numbers in the right side and the left side. So another thing to point out was that, can you notice that there is no element anywhere? Like this is a compound, this is a compound, this is a compound, and this is a compound. So if we compare the previous reactions, which were redox reactions, there were elements involved. For example, in this reaction, zinc was an element, copper was an element separately. In this reaction, fluorine was present, iodine was present over here as well. Let's go above more. Calcium was present, hydrogen was present. So as you can see, there is always an element involved in a redox reaction. So I guess we can now draw a conclusion that there were no elements present in this, and because there were no elements present, it was a non-redox reaction. Hence, we can now narrow it down to say that a reaction which does not include an element will be a non-redox reaction, as it will have no change of oxidation numbers. Right. So now let's look at more examples to just be reassured of what I have said just now, this above statement. Okay. Now this is equation number 4. So there is sodium chloride plus silver nitrate will give me silver chloride and sodium nitrate. Now first thing first, let's look at the radicals that are involved over here. So we wrote down above that NO3 minus 1 is a radical and it has a charge of minus 1. So let's locate NO3 over here. I can now see NO3 is a charge of minus 1, NO3 has a charge of minus 1. Now sodium belongs in group number 1, so it has a charge of plus 1. Chlorine is in group 7, so it has a charge of minus 1. And silver is a transition element. Now in order for this compound to be overall 0, silver has to be a positive 1, because the second rule of oxidation number was that the overall oxidation number of a compound is a 0. So in order to cancel out this minus 1, it needs to be plus 1 in order for it to be overall 0. Same thing for this one. Chlorine is a minus 1, silver is also a plus 1 over here. And to cancel, because sodium has a group and it has a charge, so it will be a plus 1 over here. So let's just take a good look at what is being oxidized and what is being reduced. And what is changing here? Nothing is changing because there is no element involved. All of these are compounds. So I still put all the oxidation numbers so you guys know what we're talking about here. But a quick pro tip would be that if the question asks you that what is it a redox reaction, you will just look at the element. If there's an element involved like sodium or chlorine separately, it's written like this, so it will be a redox reaction. But in this case, they're all compounds, so it will not be a redox reaction. All right, so let's move on to another equation. Equation number 5. We have 2 MgNO3 will give me 2 MgO plus 4 NO2 plus O2. No need to worry about the balancing of this equation. We will talk about balancing in another video. So let's just let's do the old ritual and note down the oxidation numbers. So magnesium belongs in group number 2, so it will be a plus 2. And now NO3 is a radical and it has a charge of minus 1, but notice that there is no NO3 on the product side. This was the reason why I said that check on both sides in order for you to be sure that they are both present. So because of this reason, I will need to work out NO3 separately. So oxygen will be a minus 2. Let's go with minus 2. Magnesium will be a plus 2. Oxygen will be a minus 2. And oxygen will be a minus 2. And it will be a 0 because it's an element. Right. So I don't have the oxidation number for nitrogen in this whole compound. So what we can do here is that just write down 3 minus 1 as a whole. Now I need the charge of nitrogen in this compound. I will do the whole thing. Just write down the oxidation number of minus 2 of oxygen because it is minus 2. So x minus 2 times 3 is equals to minus 1. I hope you understand why I'm equating to minus 1, because the overall charge is minus 1. So let's just solve it. So x minus 6 is equals to minus 1. Now x is equals to minus 1 plus 6. So minus 1 plus 6 is going to be a plus 5. So in this case, nitrogen will be a plus 5. Let's go ahead and write plus 5 over. Now I did only use NO3 minus 1's radical, so because you do not need to do the whole this compound, right? This will only make things complicated, so why not just take the NO3 minus 1 and just solve to get what nitrogen's oxidation number is. Another pro tip is that try to break down complex compounds like I have done over here. It will just make your life easier. And now let's go ahead and figure out what's being oxidized and what's being reduced. And one more thing, I forgot to take out the charge of this particular nitrogen. Let's go ahead and do that. So we have NO2, so it's a minus 2, and it's an X, overall is 0. X minus 2 times 2 is equals to 0. X minus 4 is equals to 0, so X is going to be a plus 4. This was pretty easy. Let's just remove all this and write down a plus 4. So figure out what's being oxidized and what's being reduced. You can pause the video and solve it for yourself. Let's go ahead and isolate the elements. We have magnesium first, so it's a plus 2 and a plus 2 over here, so nothing is changing. For nitrogen, we have it's going from a plus 5 to a plus 4. Yes, something is happening over here, so nitrogen is being reduced because there's a decrease in oxidation number happening. As for oxygen, we have a minus 2 over here and a minus and a 0 over here, right? So it is being oxidized because minus 2 to a 0, it's increasing, so it will be oxygen is being oxidized. Right, so let's move on to the last equation for this class, which is equation number 6, which I have as 2Na plus 2H2O will give me 2NaOH plus hydrogen. Right, go ahead and write down the oxidation numbers. I'm just going to go through this one very quickly because we have done very similar equation to this particular style. Hydrogen is a 0, sodium is a 0 because it's an element, oxygen is a minus 2, and hydrogen is a plus 1. Go ahead and write down that. And because OH is not present on this side now, I will just go ahead and solve it separately. So plus 1 for sodium, minus 1 for hydrogen, and plus 1 for hydrogen, and a minus 2 for oxygen. Let's figure out what's being oxidized and what's being reduced. Sodium is going to be a plus 1, so it is being oxidized. Sodium is being oxidized. As for what's being reduced, let's go ahead and isolate hydrogen. So it's a plus 1 over here and it's 0 over here. So hydrogen is being reduced. Okay, so let's wrap up this class with 3 equations to solve on your own. We have done a lot of equations in this class. So if you still have a little bit of confusion, I would recommend to just rewind the video and then pause the video at the exact instant before I solve it, so that you also have some practice on how to solve the equations by yourself. So this is your homework assignment. As always, we will discuss this in the next class. So these are your homework equations. As always, we will solve them in the next class. So let's just go ahead and simplify them as well. Now this is an equation that we did solve in this class. It's a very similar one, so this shouldn't be too problem. This is also a very simple equation. This should also be no problem. Now methane. Now for oxidation number of methane, we can't find out in our syllabus, so I'm just going to go ahead and give you the oxidation number of methane. Hydrogen is a plus 1 and minus 4. Okay, so I hope you can do all this by the next class. Now we will not talk about equations from tomorrow, as we have done a lot of equations in this particular class. The last topic that we have for this redox reactions topic is oxidizing and reducing agents. That's a very fun topic, so stay tuned for that video. As always, if you have any queries regarding this lesson, I would recommend you to drop a comment in the comment section below so I can respond to your queries. This brings an end to lesson number 4 of redox reactions. Take care of yourself, and I will see you in the next video.